and welcome to the next part of this video tutorial series on how to create your first DirectX 12 application in C++ from scratch. During our previous episodes, we started the process of creating the whole graphics pipeline outlined in episode 11. During our last episode, we got done with the wrapper for the shaders and their compilations. We created a shader which contains nothing. Next, we want another prerequisite for the whole pipeline in terms of rendering. And let me just close some of this. We don't need that for now. We will be doing the root signature. I was contemplating whether we need a wrapper for the actual input state slash input layout. It's actually called layout in DirectX 12. Yeah, but we'll see what we think makes the most sense. We will create a wrapper for our root signature, and we will discuss that more in detail. We will make sure that we have our namespaces set up. There we go. And of course, in our CPP file, we want to do the same so that we don't go insane. All right. A root signature is something that, as many other DirectX related API calls, does have a interface. That was the word I was looking for. So we want a ID3D12 root signature interface. We want to be able to create a root signature that is a simple and nice root signature, which will basically be a root empty root signature here. We of course want our mandatory release function, and then we also want a destructor here. Let's implement all of these methods. Let's see, our destructor should call our release function. Our release function should check if we can actually access our compiler, if it has anything assigned rather. And our excuse me, our well, maybe we don't want a default constructor because, or rather, maybe we don't want to specify the default constructor because actually, how do we create a root signature? DirectX 12. Well, let's see. Creating a root signature. Blah blah blah. We need to specify some information, serialization, create root signature. So we need our device. This means that we would rather initialize it afterwards, at least how we do things in our program here. Pointer to the device. So now we can create an empty root signature, which is basically not empty, but it's just containing not anything. Well, our create root signature function takes in a blob with the root signature and somewhere to store it. But maybe we find that to be somewhat bothersome. Maybe we can use this serialized root signature, since it basically just stores it in a blob instead. Maybe that makes more sense. Let's see. Do we like that? Well, okay. Generally, this says that this creates a root signature of a specific type, version 1.0. It has been superseded, which means that we can create any version. What's the difference between the versions? Well, root signature version, blah, blah, blah. Okay, we can do more elaborate instructions in terms of descriptor heaps. We won't be bothering with that, so we will just use our old root signature. That will probably be fine. In any case, we want to, let's see, call this function to serialize a root signature that we can pass along to our create root signature method. So in our create root signature method on our device, we don't need a node mask. We need our blob with the serialized root signature. We need the length of the blob, and then we want to store our API pointer on somewhere. That somewhere will be our com pointer, underlying pointer here. So I think we should start with actually doing the serialized root signature, and that takes a version root signature description, which is this struct here. So we will fill out that root signature description here, and we will see if we can initialize it as 0. That we can. We will do a version 1.0, since we don't want to mess around with the different setups of the descriptor heaps. That's a more advanced topic and optimization based, so we don't care about that. We are only doing a simple application for now. So, well, this contains a union that contains this struct here. It wants a number of parameters in the root signature. Remember what I talked about in the overview episode. The root signature is sort of an input description in part on some components of the pipeline. So it takes a number of parameters. It also specifies a certain array which has a pointer that holds the actual parameters. As you can see here, you have to specify the number of static samplers and a pointer to the description of those static samplers. Then we need some flags. Let's see. As you can see here, if we plan on using an input assembler, which we do because we have input, we can specify a flag that, or rather, if we don't specify this flag, we can't access the input assembler. We can tell the pipeline that it's allowed to do certain stuff and not to allow certain stuff. It's basically related to the pipeline diagram that I showed you earlier. Yeah. So there are a lot of different options in terms of the root signature. We will get back to the root signature now. Okay. I think that we will actually, if we were only to do 2D rendering, we wouldn't actually need a root signature. But since I think that this tutorial series is probably a bit more interesting if we ever do 3D rendering, even though it's just simple 3D rendering, I think that we will actually show you, or rather I would show you how to set up a certain root parameter. We will create one root parameter with our standard root signature here. We could easily create a root signature that didn't have any parameters, and then it's just an empty root signature. But what would you get from that? Well, I don't think you would get anything out of it, and you would be no smarter in terms of handling root signatures and understanding what they actually do. So therefore, we will simply create a root signature with one parameter. And that parameter we will in the future use to do 3D rendering. So that is our sole purpose of our root signature here, to allow us to create one input. Let's see. We will put in one parameter, and we will have to create a parameter struct, a root parameter structure. And not num parameters. There we go. And we need to create our root parameter array, which will hold one parameter. And let's look up the structure here. It has a parameter type, which will be a constant buffer view, because we can put in constants, we can put in constant buffers, we can put in tables of different buffers and resources, or we could put in a shader resource view, which is usually a texture, or we could do an unordered access view, which is just data points, maybe outputs from different pipelines and so forth. We will do a constant buffer here. Let me copy this because I don't want to type it every time. As you can see, then there's a union in terms of a constant, a table, or a descriptor. We have chosen a view slash descriptor. So let's see, we need to specify a register space. Let's see, and we also need to specify a shader space. If you look up shader, HSL, register space, resource binding, you can see in this documentation that, let me see, do they have a nice image of it? No, they don't illustrate it graphically. Anyway, as you can see here, constant buffer views are stored in a shader register called B. unordered access views are stored in a U register, and the SRVs are stored in a T register. The registers can be subdivided so you can have parallel registers in so-called spaces, so space 0, space 1, and so forth. So that means that we register-wise would like the 0 register. We would also like the serial register to be 0 because we want this parameter to be stored in the first index for a constant buffer, meaning it will be stored at B0, T0 register space. And we don't need to specify the T0 unless we use it. So a constant buffer. Now we can put in the address of our parameter here. There we go. And we basically have our prerequisite requirements for our serialization of a root signature. Let's see. Now we want to call our, there we go, versioned serialize. Okay, and this returns an H result, as you might quickly have been able to grasp or see. Eval H result. We want to do this. It doesn't need a device. It's simply just a method that we pass in our root signature description. We give it a blob. So we need to define a blob. Pointer to our serialized root signature. And as with the shader compilation, we would like an error blob just in case. You need debugging, so we pass it the serialized root signature and the pointer to the error blob. And then, of course, error serializing the root signature. There we go. And then, since we stored our root signature, we can create the root signature. Also returning an H result, most of these functions do, so even though I didn't show you in the documentation, you can usually and then we ask how big is this, and then we want the IID, PPV, args. I always put in the H as if I'm shouting in pain, but I'm not shouting in pain. Error creating the root signature. There we go. We could do some error parsing if we wanted to. Maybe we want to, if the error blob actually is available, maybe we want to print wide character new. Isn't that the one that we used in the shader? Let's see. No, we actually just do like this. Let's just copy that. Only the, oh, I used a P here instead. Okay, whatever. All right. And that's it for our root signature. Let's test out this wrapper here. Maybe he will do some nice beats. Wah, wah, wah. Or better than she. I think that's more appropriate. Anyway, let's move on from that terrible joke. Let's do a root signature here. And we want to initialize it. And we want to give it our device. And let's see what happens. Does it compile? We have some kind of access violation. Problem serializing the root signature. Okay. So we might have some mistake here. Oh, I think we forgot something. Or rather, I forgot something. Not here. In here. We of course need to tell the root signature which version we're trying to compile. There we go. I think. Well, we still do get an error. Okay, we also didn't specify a shader visibility. We also forgot that in our root parameter. Yeah. Let's see. Good stuff that are compilation steps here do give us some error handling. Okay, I forgot those parameters. There we go. Everything got created successfully. Whoops. Root signature serialization error. There we go. Okay. That's our root signature. Our root signature currently has the layout that in the first slot of all the parameters in our root signature is reserved for a constant buffer view, meaning that we can simply store an address to our constant buffer, preferably on the GPU. It will be visible in our vertex shader, and it will get compiled with our generalized root signature. This is our standard root signature. You could do several different root signatures if you wanted to. They are stored in the COM pointer for the specific root signature, meaning that if you create separate pipelines, they would be able to hold different root signatures. Okay. Well, that is basically it for the root signature. I'll be doing questions if there are any. Currently, it doesn't seem like it. All right, I'll end the recording here. In the next episode, we will be creating. Maybe we will do the input layout wrapper since it should be fairly short. Otherwise, we will just create a standard input layout. Well, I'll ask if anyone has a preference. Yeah, but anyway, that's up in the next episode. We will probably do the input layout as well as the pipeline state in the same episode. So that's up next. Either way, we're working on the pipeline. All right. Hopefully, I'll see you in the next episode.